Hello, welcome to Marshable Math. Get your pencil, paper, calculator, and let's talk about some proportion problem solving. So let me share my screen with you. There we go. Now, if you saw the video on ratio, or if you know what ratios are, you know that ratios oftentimes look like fractions. They're not exactly fractions, but they are comparisons between two values. Usually you write them as a fraction. And the key thing there is that it's the relationship that matters, not the individual numbers. So when we look at these two ratios that are set equal to each other, I'm certainly not saying that 5 is equal to 10.2 or that 12.5 is equal to some other thing. But what I am saying is that the relationship between the numerator of 5 and the denominator of 12.5 must be the same. The relationship must be equal to the numerator over here, 10.2, and then divided by whatever the unknown variable is there. What is that? What is that? What number do I put on the bottom so that it has the same relationship as that first fraction? So the way that you would solve this is you've got four spots. You've got top, bottom left, and top, bottom right. And you'll know three of the pieces, and you have to solve for the unknown one. So what you do is this. You're going to take the two numbers. X then must be equal to two numbers that get multiplied together, and then divide by the third. So what two numbers get multiplied together? Those would be the two numbers that are actually diagonal from each other on the proportion. You don't know what x is, so it's not the x and the 5. It's the other two numbers. Whatever two numbers that you know that are diagonal from each other, you multiply those together. So this is going to be 12.5 times 10.2. And then you divide by the thing that's diagonal to your variable, wherever it is in the proportion. You can maybe sometimes you're going down left or up right or whatever it is. You're always going to divide by the thing that is diagonal from your variable. So divide by 5. And then I'm going to get out my calculator. There it is. And I'll just run the numbers, 12.5 times 10.2, and then divided by 5, and get 25.5. So there's the answer. Now that would not be something that I really could, use my imagination to figure out. A lot of times when you first learn these, they give you easy ones. Like if this number over here instead of 10.2 was just 10, you would say, well, 5 times 2 is simply 10. And then you would say, well, just multiply this number bottom by 2. But like 5 times what is 10.2? I don't know. That's not very comfortable numbers. Those are not integers. So this method of multiplying the things that are diagonal from each other and then dividing by the thing that's diagonal from your variable, that'll always give you the right answer. All right, so now let's put this to use to do some problem solving. One of the things that you'll use to solve problems with or to answer practical questions is money. So if $1 is equal to 0.91 euros, convert $27.64, see the dollar symbol, into euros. And sometimes you may be looking off of a reference sheet where they'll tell you, $1 US is this, or one Mexican peso is this, and so forth, or whatever. 1 British pound is this, to how many dollars, whatever. Just my advice is just to write down the straight conversion. What do you mean, Mr. Marsh? Just write down $1 is equal to, in value, that's what you're being told, 0.91 euros. A euro is the money unit in the European Union, which is what is that now? England, France, Germany, that group over there. So if you're traveling over to Europe, you probably won't be able to buy things in dollars because it's the United States money. You have to convert it over into European money. There's always a fee involved in that too. But anyway, so we got $1 is equal to 0.9 euros. And then I just make proportions out of them. I draw a fraction bar right there and a fraction bar right there. Bada bing. Now, what do I actually know? Convert $27.64. Now, is that going to go on the bottom right or on the bottom left? Well, because it's dollar, you have to go with dollar over here. It's got to be in the dollar fraction. So on the bottom over here, 27.64, And then how many euros? I don't know. That's what I'm being asked to solve for. There we go. There's the proportion. And setting it up is probably 3/4 of the math, 3/4 of the thinking that's really involved in this. You have to set it up right. You can't just put these things anywhere you want to. You've got to be consistent with the relationship. If I had somehow written it where it was euros on one side is equal to dollars on the other side, it would have to be euros on the bottom on the left and dollars on the bottom on the right. So long as you're consistent, it will work. But you have to be thoughtful and deliberate and not silly about where you put the things. I say the pencil's the tool of the mind because the space on the paper guides your thinking. And what you have written in that space on the paper fashions where your mind is going to go if it goes anywhere. But since we got it set up, we really are going somewhere. But not to Europe. I'm going to stay here in the United States. So E is equal to 2 things multiplied divided by a third. What 2 things multiplied? Find your 2 numbers that you do know and multiply those together. So 27.64 and then 0.91. And then we're dividing by the thing that's diagonal from the E, which is just 1. And even though it does nothing for you mathematically, you need to go ahead and write the 1 in there so that you know what goes in that spot and you're not scratching your head like, gee, I only got half the problem written down. Okay, so now we'll run the numbers. 27.64 times 0.91 equals, and then I get this strange number. Can you see that? 25.1524. How do you write that? Money always has to have 2 decimals and 2 decimals only. So 25.15, and then the number after the 5 there, the second 5 is 2, which is not 5 or higher, so I don't round up. 25.15 euros. Oops, can't see the unit there. So that would be my answer. And it would be the same thing if you set it up with euros on the other side. It doesn't matter. Some people will do it a little bit different way. I'm going to show you one more little proportion way. Instead of going left to right, like the way I was doing, dollars to euros and then dollars to euros, they'll do dollars to euros down and then dollars to euros down. It really doesn't matter which method you use, provided that you are consistent with the pattern once you choose what it is. So $1 is equal to 0.91 euros. They'll say $1, and please write the unit in there. Don't just write 1. You have to understand the meaning of what's in that space. Is 0.91 euros. That's the first situation right there. Okay, and then the second situation is then this fraction. So where I was organizing it sideways, they were organizing it down. So then would be, what goes in the next one? Dollars. 27.64, and then the E would go down here in the bottom. This will get you the same algebraic arrangement if you do it that way. But you got to be consistent. You can't switch things around in the wrong spot. Okay, now let's do a measurement question. Convert 60 gallons into quarts. Gallon is the United States and used to be British measurement system of volume. It actually was British. It was the imperial system. Gallons, quarts, ounces, cups, that sort of thing. Quarts. Do you know how many gallons are in a quart or how many quarts in a gallon? If you don't, start small. And I'm just going to set up my proportion. Line, equals sign. That was rhymey. And I'm going to do, it's gallons to quarts on there. I'm just going to write GAL for gallons and QT for quarts. Now, which one's the bigger unit? Maybe you don't know, but you should. You should learn these. You're going to be using them quite a bit. A gallon is a bigger unit, so I'm going to put a 1 right there. 1 gallon. The 1 always goes with the bigger number, and then you have a certain number of the smallers that make the bigger. How many quarts in a gallon? If you look it up on your reference sheet, you should see 4 quarts make a gallon. Okay? So literally, that's what would be written on your conversion sheet or your reference sheet if you've got one. 1 gallon equals 4 quarts. And I just write that down and put fraction bars underneath them, and then I proceed with what I actually got. How many gallons do I actually have? Well, that would be 60. 60 what? Gallons. I cannot write 60 down over here on the bottom right. That's the quart side. You have to keep it straight. So let me do my little magic teacher electronic trick and move it over here. Ta-da! There we go. All right, 60 gallons. Maybe even write in gallons again if you need to. Gallons. How many quarts? I don't know. I'll make a Q for quart. You can use X, whatever. But like I try to use variables that make sense with what I'm talking about. Okay, pretty easy now. Q is equal to two things multiplied divided by a third thing. What two things multiplied? We'll find the two numbers that you actually know, the ones that are not diagonal from the variable. That would be 60 and 4. So 60 and 4. And then divide by the thing that's across from your variable, 1 again. So just 60 times 4. And then I run that. Oh, 4 times 6 is 24, and then throw the 0 on there. 240 quarts. That's actually quite a lot. Isn't does 7-Eleven still do like the Slurpees or something like that? I seem to remember like it was you could get the quart thing of a Slurpee, which would give you brain freeze or something like that. If you drank 240 of those in a day, you'd probably be dead. I'm sorry, that's just what I was thinking about at the moment. All right, so now convert 8 hours into seconds. How many seconds in an hour? You know, you really don't know. You probably know that there's 60 seconds in a minute and 60 minutes in an hour, but you maybe not know directly from seconds into hours. Now, this one's simple enough where maybe you could figure out how many seconds are in an hour and do it. But what I want to do is I want to give you an example where you're going to have to do 2 or more exchanges in order to get your final value. So I'm not going to go 8 hours directly into seconds. I'm going to go 8 hours into minutes, and then take that minutes and then move it into seconds. So let me do 8 hours to minutes first. So line equal sign, hour on the left, just because it's the first thing when I read it. Minute on the right. You can do it backwards, it doesn't matter. Just don't mess up the pattern. Now, which one's the bigger unit? An hour is bigger. How many minutes in an hour? 60. And now let's put down the thing that I know. This is the top row here is just the conversion. It's the theoretical. On the bottom is the actual. How many actual hours do I have? 8. How many minutes do I have? I don't know. I'll use M for minute. M then is equal to 2 things multiplied divided by a third. Stop the video and see if you can go all the way to the end. I dare you. Go. Are you back? Like I really won't know. It's between you and heaven, like whether you actually did that or not. Okay. So take the 2 things that are multiplied and multiply them together, or diagonal. So that'd be 8 times 60 divided by the thing there. That would be 1. 8 times 6 is 48. Times the 10 would be 480. This is 480 minutes. But now I have to do it again to seconds, and so I'm kind of running out of room there in the bottom. Let me go over here and I'll start a new proportion. Line. Oh, my face is in the way. Okay. Line, equal sign. What am I doing? I'm doing minutes into seconds. Which one's the larger unit? A minute is the larger unit. How many seconds in 1 minute? 60. And now what have I actually got? I've got 480 minutes. It goes under here. 480 minutes. How many seconds? I don't know. I'm not going to use S for a variable. It looks too often like a 5. It causes problems. So let me just do T for the final time. So T, I'm at the bottom of my paper here too. T equals 2 things multiplied divided by a third thing. And so it's 480 times 60. And then divided by the 1. And so I get a final time of, I can't do that in my head. 480 times 60, and that equals, holy smokes, 28,800. Got to put a unit on it. Seconds. So there's an example where you have to know an in-between, because you don't know the 2 things connected directly, but you know an in-between one. It's like a little link in the chain. So aren't you in school like for about 8 hours a day? So what does that mean? It means you probably spend 28,800 seconds in school. Is it worth it? Are you getting mentally stronger? Don't waste your time. Your school time won't ever come again. I actually heard a lot of adults, myself included, say that, man, I wasted too much time in school. I wish I could go back and do it over again. But once you're out, you can't. You got to be responsible for your learning on your own for the rest of your life. So make good use of the time. See you later, alligator. Bye-bye.